Again, we are given the marginal demand. This is the function. They're giving us a point. When x is $3 per unit, the demand has that amount, which is a point. They want us to find the function, not the total something. They want us the function, which is the most general antiderivative, in which we have to plug in this point. Not yet, of course. So this is the indefinite integral from d prime of x dx. I copied the function, and now I need to find the substitution, and I need to find the differential. Otherwise, I cannot move on. Can anyone give us the substitution based on what we just discussed a few minutes ago?
It's 25 minus x squared.
Very good. And now we need dy.
Some negative 2x dx.
Very good. This is it. So let's see what we have. Let's see what we don't have. We cannot make up x, but we can always play with a constant. So obviously this is our y, the square root of y. Obviously I have the dx and I have dx. I need a negative 2, meaning I'm going to play with this 2, negative 2,000. I'm going to connect negative 2 to x and dx, but the other 1,000, I'm going to put it outside. Negative 2 times 1,000 is negative 2,000, but I will group them in the following way. Negative 2x dx will be dy, and the denominator is the square root of y. So let's see what we have left. So the 2,000, I'm sorry, the 1,000 is outside. The integral from negative 2x dx is dy, and the denominator is the square root of y, or y to 1/2. We have to bring it up as y to negative 1/2, and then increase the power by 1, divide by the same number. Since it's an indefinite integral, I must return to the original variable. I have no choice. So I have 1,000 outside. This is y to negative 1/2 plus 1. So it will be y to 1/2 over 1/2 plus a constant c. I replaced 1 over y to 1/2 by y to negative 1/2. And then I increase the power. Negative 1/2 plus 1 is 1/2. I have to divide by the resulting number plus a constant c. I have no choice but go back to the original variable. So this is not finished. So therefore, I have 2,000, the square root of y, which is 25 minus x squared, plus a constant c. Now I will use the point 3, 13,000. So for now, let me write it one more time. What we got was that d of x is 2,000, the square root of 25 minus x squared plus a constant c. They're giving us this information to help us find the constant. So we can find not the most general antiderivative, but the unique function that complies with the given conditions. What conditions? Its derivative is this and also passes through this point. Good. So then when I replace d of x by 13,000, then I get 2,000 times 25 minus 9 is 16. The square root of 16 is 4 plus a constant c. So 2,000 times 4 is 8,000, subtracted from 13,000, 6, c equals 5,000. Therefore, now we have the unique function, which is 2000, the square root of 25 minus x squared plus 5000. Now, this function is guaranteed to have this derivative, and it's also guaranteed to pass through this point. So we found the unique demand function given the marginal demand. So this was an application of the indefinite integrals. Any questions on this problem?
On the part where
Yes.
you have dy over y to the 1/2. So why? I thought it was you added 1 to the exponent and then put it over both of that. How is it still 1/2? Is that because it's in the denominator there?
Yes. So I replaced this. Let me write it here. So we had 1000, the integral from y to negative 1/2 dy. 1000 y to negative 1/2 dy is the same with 1 over y to 1/2.
Gotcha. Okay, thank you.
That's okay. Let me explain, because most probably others did not fully follow that. So I increased negative 1/2 by 1, and I get 1/2. And I have to divide by 1/2 plus a constant c. I cannot work with y to 1/2 in the denominator. I have to bring it up, but when I bring it up, I have to change its sign in the power. So then, when I move from here to the next step, I have to increase the power by 1. Negative 1/2 plus 1 is 1/2. And I have the obligation to divide by the same number. And then plus a constant c. Is this clear to everyone, please?
I'm good. Thank you.
Thank you. Everyone else? Is this okay? Okay, now let's look at an application with a definite integral. Any questions on this? Okay, let's look at the marriage rate. The marriage rate in Nevada is approximated by, and they're giving us the function. So here it is. So the function is in 79, m of t equals 38.045 times e to negative 0.045 t. M of t is the number of marriages per 1,000 people per year. Of course, it has to have two measurement units, is the rate of change. So this is basically a derivative. T years after 2010, which means 2010 is t equals 0. And now let's read the question. Find the total number of marriages. So find the total number. Not find the function, which is the indefinite integral. Find the total number of marriages per 1,000 people in Nevada from 2010 to 2015. So 2010 is t equals 0, and 2015 means t equals anybody? If 2010 is t equals 0, 2015 is t equals
5.
Very good. So we're asked to find the total number, which is the integral from 0 to 5 from this function, 38.45 times e to negative 0.045t, of course dt. There is no integral in t without dt. There is no integral in x without dx. Good. Of course, I have to worry about a substitution and then dy. Although we did find, or we did discuss this before, for e to a number like that, we don't really need a substitution because we know how to handle this, but if you remember, I can review that with you, or we use a substitution. It's in your notes from a couple of weeks ago, or we use a substitution. Anybody, please?
Can we do the other method from a couple weeks ago?
Yes. You want me to refresh your memory on that?
Please.
Of course. So if this is too easy, I think, to use the substitution. I completely agree. So remember when we differentiate e to 3x, we get e to 3x times the inner function prime. When we integrate e to 3x dx, we have e to 3x divided by 3 plus a constant c. Here we multiply, here we divide. Because when I differentiate this, I get this, and 3 has to go away. So this is the same situation, it's just that this constant is not a nice number like 3, but it's this. But the idea is the same. So I agree, when it comes to e to a constant times the variable, there is no need to use a substitution for that because we have a very simple method. So if we continue accordingly, then from here, we jump over here. I have to have the 38.045. I have to have e to negative 0.045 t divided by negative 0.045. And of course, from 0 to 5. If I use a substitution, then I have to also find dy. I also have to find new limits of integration. But if I use the straightforward integration, which I highly recommend, I don't have to change the limits of integration because I didn't change the variable. I did not use a substitution. And I just plug in 5 and subtract when I plug in 0. Let me know when I can continue with the problem. Is this okay? So in my example 3, in this example negative 0.045, and the same procedure. Good. So then I have to divide this by this. It's a negative number. And I'm going to divide by it right now. Let's just divide. Although I would rather just do everything in one step. So let's leave it alone for now. When I plug in 5, when I plug in 0. So it's better to, better to put everything in one step. So I just kept these two numbers right here in front. I plugged in 5, which means e to negative 0.045 times 5. But when I plug in 0, e to 0 is 1. So let's calculate. So negative 38.045. Oops. Divided by 0.045. Okay. I'm going to put it in parentheses. Good. And I open another parenthesis, and I have E, and the power is negative 0.045 times 5 close, and then minus 1, and then close again. Okay, so 170.34. per thousand. Any questions on this situation? Again, we were asked to find the total number of marriages per 1,000 people in Nevada from 2010 to 2015. And this is the total number. When we're asked to find the function, we use the indefinite integral. When we're asked to find the total number, we are basically asked to determine the definite integral, calculate the definite integral. This is the end of chapter 4. I highly recommend complete the work between now and Wednesday, sorry. Now in chapter 5, so notice in chapter 4 we only looked at 4.1 through 4.5. That's it. Chapter 5 deals with applications of integration. And we look at 2 applications. This is only 5.1 and 5.7, just 2 sections. Number 1, consumer and producer surplus. I'll explain what that means. It's an application of integration. Consumer and producer surplus. The last one, which is section 5.7, is called differential equations. Differential equations. Not that I want to scare you, but this is the most intense topic in this class. Okay, so I know we only have like 8 minutes left. I will stop as a token of respect in 8 minutes, but I'd like to at least introduce the idea of the consumer and producer surplus. Okay. And they can be determined at any point. If you remember, we talked about the equilibrium point. We don't need the equilibrium point. We may be asked to find the consumer and the producer surplus at any point, including the equilibrium point. So this is X, number of units, and this is price per unit. Number of units, price per unit. The equilibrium point. If you remember, we determined in the past, the equilibrium point where at this number of units and at this price per unit, so I'm going to say X and Y, everybody was happy. Okay. So this was the demand function, and this is a supply function. And this is the equilibrium point. Equilibrium point. Here's what happens. Notice that between 0 and X, under the demand function, there is an area. And this area is composed, and I'll explain, I didn't explain what the consumer producer surplus are. I'm going to explain right now. So we graphed these, or they were given to us in the past, at the beginning in chapter R, a long time ago. We were given two functions. We were asked to intersect them and find the equilibrium point. And we found for the number of units and the price per unit. But now I want to discuss something else. We know how to determine areas under a graph. So under the demand function between 0 and x, I can determine this area. Can anyone tell us how will I determine this area under the graph of d of x between 0 and x? What do I have to write? You had it in homework, we had it in class. How did we determine the area under the graph of a function between 0 and x? Let me change this into a and b. It doesn't matter. I don't want you to think it's the equilibrium point, let's say, is a comma b. How did we determine the area under the graph? What did we need to calculate?
The area of the sections?
Correct, but what did we calculate exactly to find that? Yes, exactly. The what?
Sum.
Exactly. The definite integral between 0 and a from dx, from d of x dx, right? We calculated the definite integral, right? In order to find the area under a graph between 2 points, we determined the area, calculating the definite integral between 0 and a under the graph, correct? We remember that? Perfect. Now notice something else. I have a rectangle here. Can anyone give us the area of this rectangle? Area of rectangle. What is it? Base times height. A times B. Do you agree with the area of this rectangle as being base times height? Okay, stay with me. Now, this area is what we call consumer surplus. What is it? What is it? We are happy with purchasing 5 units at the price of $3 per unit. It's an example. So 5 units, which is A, at $3 per unit. If I purchase 5 units at $3 per unit, I am getting some extra value in my purchase. How much will I pay? $15. This is what I'm going to pay, right? 5 units times 3. 5 times 3, I pay $15. Yes, I pay $15 for 5 units at the price of 3 per unit. But this orange area is my extra value. Maybe it consists of my content that I purchased 5 units at $3 per unit. Maybe it has extra value. It's called utility, the extra, consumer surplus. How will I determine, and then I'll stop. we're not gonna calculate anything right now. We'll calculate on Wednesday. Consumer surplus, which is the area in orange, obviously is the total area, which is this, the integral from 0 to a from d of x dx, minus the area of the rectangle, which is AB. This is the formula. So the consumer surplus is the total area under the graph of d of x, subtract the area of the rectangle. It's just, and this will be in dollars. This will be in dollars. And we're going to look at examples. And then we're going to talk about the producer surplus. And we're going to be able to determine them, both for any point, including for the equilibrium point. Please finish up all the work for chapter 4. Please. I didn't mean to turn this off. I meant to do this. Let me stop this.